Okay, so I want to tell you a little bit how Jupiter is used in solar system exploration as a gravity assister, or Jupiter and gravity assist. Let me tell you what it's about. So suppose here you are on Earth with your rocket and you want to get to Jupiter, maybe to send a probe around and take some pictures or measurements or whatever. As I might have mentioned in a previous video with this gravity, is we don't ever travel in straight lines in outer space. So we wouldn't say turn on the rocket's engines and start to go in this direction, you know, with a bunch of fire and stuff behind it, sort of going in this direction straight onto Jupiter. Okay, that just doesn't happen. So we don't know straight lines. And the reason why we don't travel that way is because we just don't have enough fuel. Rockets barely have enough fuel to sort of get them to escape the Earth's gravity, as we mentioned in a previous video, but we certainly don't have enough fuel to, say, burn an engine all the way to where we want to go. So what we would do instead is maybe we'd actually, on our way to Jupiter, we might actually first aim our rocket at Venus. Now, why would we do that? It might look like the exact same launch and the exact same rocket, but maybe we would put it on a trajectory that would sort of send it out this way, and it might even say go around Venus like this, go around maybe once, you know, or even twice or something like that, until it gets flung out in the direction of Jupiter like this. And this entire interaction right here, this loop around the planet you see here, is all done with no fuel, all gravity. Just all gravity's doing it. Now, how can gravity do that? Well, you know now the law of gravity, that if you have a little space probe, maybe that's right here, then Venus in this case here is going to pull it down with its force of gravity, just the good old force of gravity that we discussed quite some time ago. And that force, it turns out, can do some kind of amazing things in terms of slinging space probes and things around planets on their way to, say, other planets. So let me show you another couple examples of that here in terms of an animation. So I have our orbit simulator all sort of queued up here. And what I'll do then is, this is just the Earth and a satellite. And so what I'll do is I'll just sort of take the satellite and I'll put it way up here and give it a little bit of speed, maybe in a direction like that. So what you see here then is, here's the Earth and here's the space probe. And the Earth will be pulling the space probe towards it. But of course on the space probe we have an arrow going this way for the direction it's going. So let me hit play and let me show you what happens. So the space probe kind of goes, but then you see Earth is pulling it in and pulling it in. And you can see that the arrow is getting longer. In other words, the Earth is giving some speed. And off it goes. So see, we haven't tried to achieve an orbit or anything like that, but we've definitely changed the direction, the whole trajectory of that little spacecraft relative to where it was going before with no engines. Let me just show you another example here. Let me just maybe make it a little bit slower and maybe in a little direction like that, a little straighter in. And let me run it now and see what happens. I'm trying to get a little closer to the Earth to make that gravity even stronger. But you can see now the spacecraft is definitely speeding it. Yeah, there you go. Look how big that arrow gets right there. And then off it goes. So we made a major maneuver of that spacecraft using just the gravitational pull of the Earth. No fuel required. So now in the case that I'll do now, let me reset the space probe all the way up to here. But what I can do is I can increase the size of the Earth by 2. So we're still not quite at Jupiter. Remember, Jupiter is much, much more massive than the Earth. But this is just the best example I can pull off with this particular software. And now I'll hit go and watch what happens. So look at the red arrow getting larger and larger and larger as it goes, and just gets, look how big it goes right there. Oh, I hit the planet. Okay, I didn't mean to do that. Let me try running it just one more time, but I think you get the idea about how the planet can really make a space probe's velocity quite large and even get it to change direction. So I'm just going to point it up and away just a tad bit like that. So here we go. Once again, big planet, not quite Jupiter, but look how large the speed's getting right there, and we can just zing. There we go. Look at how big the arrow got there. So we can just zoom right by a planet, and sometimes that type of orbit is actually called a slingshot, but it's definitely a gravity assist. We've changed the speed and the direction of a space probe without using any fuel. And so that's how you travel through the solar system, is you get gravity assists from 1, 2, or even more planets as you go out. Let me just show you one more then. This is actually a real simulation here about what happened when the New Horizons, which was another space probe, was sent past Jupiter. So here's Jupiter right here, and what we'll do according to the settings here, we'll let the New Horizons, again, the name of the space probe, you can see a picture of it right there, let it pass within 1 million miles of Jupiter and watch what the trajectory does. So it's going about 14 kilometers a second, and there it starts to approach Jupiter, it gets closer and closer, and watch what happens. 25, 60, look at how quickly the speed increases all the way up to about 22 kilometers a second, which is about 40,000 miles per hour. And all that was done with no fuel, just by passing within 1 million miles of Jupiter. So if you look down here at this graph, you can see we were going about 15 kilometers a second, and suddenly as we approached Jupiter, our speed went really, really high, up to 25 kilometers a second again, which is about 40,000 miles per hour. Then it dropped a little bit as Jupiter still continued to tug on it, but then we continued the speed. So we gained, look, from 15 kilometers a second all the way up to about 22, 23 kilometers a second on the way out, and that's a gravity assist. And that's what Jupiter is absolutely famous for doing in terms of solar system exploration, for doing things just like described here. And so you can just sort of picture this happening in the solar system. If you had like the sun here, and you could just draw on all your planets. Here's like Mercury, Venus, maybe Earth is over here, and there's Mars, and maybe you're trying to get out here to something big like Jupiter. Maybe I should have made Mars in red and that sort of thing, and I should make Venus in white because of all the clouds and that kind of thing. And so what'll happen is, here's Earth right here. Remember, this is my Earth right here, the blue planet. And what I can do then is I can put my rocket back on Earth and say I'm going to launch the rocket. And so maybe what I'll do, I'll launch and I'll just go around the Earth a couple of times. And then maybe I can give it just with a little fuel, a little boost, which might even send me all the way sort of doing this kind of thing, depending on the alignment of the planets. And Venus might sort of pull me in and suck me all the way in like that, and I might still be off, and I might go sort of around Mars like that. All of these things until finally I can get the Jupiter flyby, maybe some other slingshot out, maybe in this case here to Saturn. But this is generally the way you travel through the solar system on things like this. And just keep in mind that by the time we got to right about here, there was no fuel left. So there was no rocket engines going on anymore. I'm coasting here, and I used gravity to turn me here. I'm coasting here. More gravity here. More gravity right here. And lastly, a coast, maybe to another planet. So you can see how complicated indeed it can get. Like doing something like this depends intimately on the positions of the planets and where exactly you want to go. But I say once again, as I conclude here, that Jupiter is just the big helper in this regard because its mass is so large. So that's the story of gravity assists.